Hey guys, what's happening? Today we're going to learn how to rewrite radical expressions. So, what is a radical? It's a square root. So we're going to be simplifying square root stuff. All right. So you should already know some of your square roots. Like if I asked you, hey dude, what's the square root of 25? You should already be able to tell me, hey Mr. Swan, the square root of 25 is 5. And I'd be like, good job, student. That's true. And you should know those because 25 is what we call a perfect square number. We call it a perfect square because 25 is made up of 5 times 5. Therefore, we know the square root of 25 would be equal to 5. So that's what we're going to talk about today. We're going to learn how this all works and how we can rewrite radicals in a simpler way, a way that is more simple than it was before. So let's take a look at all these perfect square numbers. 1 is the result of multiplying 1 times 1, and that's why we call it a perfect square. 4 is the result of multiplying 2 times 2, and that's why they call them squares, because if I had little blocks and I said, okay, I've got 2 by 2. I've got 2 for my length and 2 for my width, then it would make a square. So that's why these are called perfect squares. 9 is a perfect square because that's 3 times 3. So its square would look like a height of 3 and a width of 3. So it makes a square. That's a really terrible square, but you get the picture. 16 is 4 times 4, and you know this. So I'm just going to write it really quick. 8 times 8, 9 times 9, 10 times 10, oops. 11 times 11, 12 times 12. So anyway, those are your perfect squares, and it really helps to know them, and you should already know a lot of them. And what we're going to do today is we're going to simplify square roots, and I'm going to show you how this is going to work, all right? We already started by talking about 25, and we know that 25 is the result of multiplying 5 times 5. So today what we're going to do is we're going to break these numbers down. Like 25, we would break it down to its prime numbers, which we already know is 5 and 5. So today you guys are going to be breaking numbers down to their prime factors, 5 times 5. And then what I'm going to have you do is I'm going to have you look for doubles. Because anytime you have doubles in the square root, it's equivalent to having that same number not in the square root. Okay? So I like to think of it as like a love story. Like those two 5s are soulmates because they're both 5s, and they fall in love and start a life together outside of their parents' house. Well, they don't have the same parents because that would be a weird love story, but anyway, that's how this works. We're going to be looking for doubles, okay? It's like they're soulmates. So like with the 4, I know that the prime factors of 4 are 2 and 2. 2 times 2 gives you 4. And since I see doubles, what I'm going to do is I'm going to be like, hey, I got doubles inside the square root. That means they need to be outside the square root as 1. They start a life together as 1. Okay, so you're looking for doubles. All right? So I could use that little trick for all of these. I'll just do one more and then we'll roll on. If I did 81, I could break 81 down into 9 times 9. But those aren't prime. 81 is tricky because I could really break that number down. I could take 81 and I could be like, okay, dude, 81 is made up of 9 times 9. So we're going to be making these things called factor trees. And 9 is made up of 3 times 3. Okay. 3 is a prime number, meaning we can't break it down anymore. So I'll stop there. I'll circle it whenever I get to a prime number. The other 9 can also be broken down to 3 and 3. So you might, if you didn't already know that 81 was, the square root of 81 is 9, then you might do it the long way. And you might be like, okay, I've got a 3, a 3, a 3, and another 3. There's 4 3s there. 1, 2, 3, 4. And remember, we're looking for doubles. So I've got doubles of 3. That's going to be outside the square root. I've got doubles of another 3. So I'm going to have another 3 outside the square root, and 3 times 3 is 9. So anyway, that one was kind of weird because there was like doubles. There's multiple doubles. And we'll see that. So that's the trick, guys. We are going to break these numbers down using a factor tree. Factor tree. And then we're going to find the doubles and pull that out of the parentheses, out of the square root. Sorry. Pull them out of the square root. They don't want to be in there. So let's do a couple examples. Follow me. First example. Let's do 75. Oops, square root of 75. There we go. That looks better. Example 1, square root of 75. So what I would do with this is I would break it down. I would take 75 and I'd be like, okay, what numbers go into 75? And first thing that pops in my head is 25. 25 goes in there 3 times. 3/4 makes 75 cents. I know 3 is a prime number, and then I'm like, okay, how can I break 25 down? 25 would be made up of 5 times 5, and those are both prime, so I'm going to circle those. And I've got all dead ends now. So what you're going to do is you're going to make a factor tree, and then you're going to say, hey, I got all the prime factors here. 75 is the same thing as saying 3 times 5 times 5. And I said we're looking for doubles. So when I see doubles of that 5, I'm like, okay, they've fallen in love with each other. They're soulmates. So they start a life together outside of the square root. But guess who doesn't have a soulmate? Guess who doesn't find love? That 3. I'm so sad. Nobody loves me. He doesn't have anybody to love him. He stays inside the square root playing World of Warcraft in his mom's basement until he's 45 years old. I don't know. So he's stuck inside with no one to love. And that's how this thing works. So there we have a simplified radical. That'll allow me to do other operations with the radicals. So I'm not even going to get into that in this video, but having a simplified radical allows me to do stuff with it. All right? It also allows me to compare it to other radicals. Let's do another example. Let's do the square root. Let's do square root of, let's do 24, and let's go a squared b to the 3rd. All right, now I got some variables in here. Cool. Well, the only thing I need to make a factor tree for is the 24. Maybe we'll do 2 and 12, and 2 is a prime number, and 12 would be 3 and 4. 3 is a prime number, and 4, that's a 4. My handwriting's really good. And 4 is 2 and 2. So I've got my prime factors. I had 3 2s and a 3. And then I've also got these a's. So remember that a squared is the same thing as saying a times a. And b cubed would be like saying b times b times b. So good thing we learned all that stuff. Now again, we're looking same deal. We're looking for doubles. I got doubles. Love, love. Okay, so they fall in love, start a life together as a 2. One single 2. They start a life as 1 2. Okay, no love for number 2 here. No love for 3. But Cupid's arrow strikes again. All right, we got a pair of A's. So put an A on the outside. And then I got a pair of B's, so put a B on the outside. All right, what I don't have pairs for is a 2, a 3, and a B. So all of those are sad and lonely sitting in the square root. At least we got each other. Yeah. All right, and I can, instead of saying 2 times 3, I could put that together, and I should put that together and call it 6. So that looks good. Whoa. So as a simplified radical, it kind of looks funky. I agree with you, but it'll allow us to do things. It'll allow me to add radicals, subtract radicals, multiply radicals, divide radicals. It'll allow me to do stuff with it if it's in a simplified form. Okie dokie. Let's get another example in here. Example tres, which is French for 7. And we're gonna go with let's go with something tricky here. Let's go with 72. Sounds like a really great number. Let's go with 72. Let's go with x to the 5th and x, y to the 1st. Well, I'm not going to write first. Only losers write first. And z to the, I don't know, let's go 7th power. Okay, so I need to break this down, and I'm kind of out of room. Let's see. Woo, magic. Let's break the 72 down. Maybe 2 and 36. 36, I might go 3 and 12. 12, I might do 2 and 6. Just the first thing that comes to my mind here. 6, I might say 2 and 3. And everything is prime. Everything is prime. Everything is cool when you're simplifying radicals. So now what are my prime factors? I got a 2, a 2, and a 2. I got 3 2s hanging out. And I got a 3 and a 3. All right, so my 72 is taken care of. With my x, I've got 5 of those. So 1, 2, 3, 4, 5 x's. I got 5 x's. Oh, no. I got a y. And I've got, let's go with that color. Let's go with that color. And I've got z's. I got 7 z's. Gross. 1, 2, 3, 4, 5, 6, 7 z's. All right, and remember, the name of the game is looking for doubles. But Mr. Swan, there's so much here. Yeah, that's why it's fun. I got a pair of 2s. That means they're going on the outside. All right, he doesn't have a partner. I got a pair of 3s. Those are going on the outside. I got a pair of x's. I got another pair of x's. Oh man, I didn't leave myself enough room. Oh no. All right, this x has no lover. This y has no lover. I got a pair of z's. I got 1, 2, 3 pairs of z's. So that means I'm going to put 3 z's out here. 3 z's. So a 1, a 2, a 3. I should have planned my spacing better. And then that last z ain't got nobody to love. So what am I left with on the inside? I'm left with a 2. I'm left with an x. I'm left with a y, and I'm left with a z. All right, all right. And then on the outside, I can clean it up a little bit because 2 times 3 is 6. X times x is x squared, and z times z times z is z cubed. All right, I know, I get it. This looks more complicated than it did when I started. It looked better when you started. It did. But remember, this will allow me to do fun stuff. All right, all right. So I hope that helped. There's also other videos on Canvas where the lovely people from Pearson walk through similar examples. So my videos are probably better because they're probably not. But you can tell me that they are. All right, have a good day. Get your work done. You're only doing 1 through 9 on that worksheet, so get it done. No excuses. Also, there's a quiz on the other side, and make sure that's done. If it's not already done, it should already be done. Change the question number 2 to what everybody else had. What was it? X squared plus 3x plus 2 equals 0. That's not what it said. Yes, it is what it said. X squared plus 3x plus 2 equals 0. So change number 2 to that. I didn't hear you. Well, rewind the video and listen to it again. Okay. All right, guys. Bye.